For this section C, rational functions. So we're going to learn how to graph a rational functions without using calculator. Okay, first, what's a rational function? The rational function is the function has a fraction form. That means as long as we have an x on the denominator, we call this function is rational function. For example, f of x equal to 2x over 3x squared plus 1. Kind of like this. As long as we have x on the bottom, we call this function is rational function. And when we have a rational function, there's two types of the function. First one, bottom heavy. The bottom heavy means the power on the bottom is bigger than power on the top. Example, this one. The highest power on the bottom is 2. Highest power on the top is 1. So 2 is bigger than 1. That's why we call this one is a bottom heavy. Top heavy is highest power on the top is bigger than highest power on the bottom. For example, if I have a 3 on the top, this function will be top heavy function. Last one, power equal. Power equal means we have a same exponent on the top and the bottom. For example, if I have a power 3 here. So highest power on the top is a 3. Highest power on the bottom also is a 3. They are equal. So we will call this type of the rational is power equal. That's a 3 different one. So first we talk about bottom heavy and the power equal because we solve these two type of the question same. And then we're doing different for the top heavy. And on the page 10, this page show how you find all those informations you need and then able to graph. Okay, domain, vertical asymptotes. The vertical asymptotes means a dashed line. And the graph will be getting close to this line but never touch and never cross. And the horizontal asymptote means we have a dashed horizontal line. And the graph will not cross and touch on both sides. We'll be getting close to this line on both sides. But it's possible to cross the middle. Okay? Just not possible to cross the both sides. That's the difference between vertical asymptotes and the horizontal asymptotes. And also, zeros. That means when the function equal to 0, you solve for x. And then interval work. Okay, I'm going to show you later by using problem. And one more thing. For the horizontal asymptotes, if it's bottom heavy, answer will be y equal to 0. If it's power equal, answer will be leading coefficient of the top divided by leading coefficient on the bottom. Make sure you read those parts carefully. And this tell you all the detail what you're going to do. So look at the first question. On page 11, I'm show you how to do this one. First step, find the domain. Domain always be the denominator not equal to 0. That's how we solve this. And then for this problem, we said x plus 2 not equal to 0. So x is not equal to negative 2. Okay? That's how we find domain. That's what we need. And all this just I show you the work. And the VA means vertical asymptotes. Vertical asymptotes is x equal to the number you have over here. Okay, I probably need a different color so able to see more clearly. HA. Horizontal asymptotes. First, you need to look at this question. Highest power on the top is 1. Highest power on the bottom is 1. So which will be equal power? When we have an equal power, the horizontal asymptotes always be leading coefficient on the top divided by leading coefficient on the bottom. So which give you 1 over 1. So answer will be 1. And the zeros. Zeros is when numerator equal to 0 and solve for x. So numerator of this problem is x minus 4 equal to 0. So x is positive 4. So that's the answer for this. That's the answer for this. Interval work. You need to draw a number line and label your zeros and the VA on this number line in order. So we have a -2, positive 4. So I should put -2 first and then positive 4. I need to pick a number before -2, any number from here, to plug in this number back to the original equation. For example, if I'm using -3, so I will have a -3 minus 4 over -3 plus 2. And when you simplify, so it will be -7 over -1. Negative over negative is positive number, so you only need to put a positive here. The positive means the graph will be above of the y-axis, because when y value is positive, that should be above of the x-axis. And then we're doing same thing between -2 and 4. If I'm using 0, so it'll be 0 minus 4 over 0 plus 2, and which is a negative number. That's why I put negative here. That means your graph between -2 and 4 will be below of the x-axis. And after 4, if I'm using 5, so it will be 5 minus 4 over 5 plus 2, so which is a positive number. So we have a positive for this one. Another way by doing this is, I need to go get a calculator. Another way to doing this is by using calculator. First, you go to y equal 2 and graph this function. So it will be change to fraction. So it will be x minus 4 divided by x plus 2. Okay. After you've done this, you go to table. And then look at all this value on the table. You can see if I'm using -4, y value is positive. If I'm using -1, y value will be negative. So that's another way, either way, to find what's the y value are positive or negative. After this step, go to y-intercept. Y-intercept is when x equal to 0. And what's the y value equal to? So for this one, if I plug in 0 here, plug in 0 here, I will have a -4 over 2 and simplify to -2. And that's what we have for y-intercept. And that's all you need for this function to able to graph. Okay. After doing that, there's something you have to draw on this graph first. So first one, I need you to draw vertical asymptotes by using dashed line. So at -2, there's a dashed line. And then we have a horizontal asymptotes at 1. So it'll be 1. And then I need you to plot the point for 0. This is a 4, so we have 4 here. And the y-intercept is a -2. That's all I need you put on the graph. Okay. Look at this, what we know so far. These two asymptotes means graph will be close to that, but not cross. These 2 points means graph will be passing through these 2 points. That means how far the graph will be go. Okay. And now let's look at the interval work. before -2, y value is a positive. So before -2, the y value will be above the x-axis, also will be bounded by these two lines. That's why your graph will be can be this way. And then between -2 and the 4, between -2 and the 4, the graph will be below of the x-axis and bounded by these two lines, cross these 2 points. So the only possible the graph can be will look like this. And now you can check by using your calculator. Go to calculator. We already did this function. You just graph. You can see we have exactly same thing. So on the test, you can use your calculator to graph, but I need you to draw the asymptotes and draw these 2 points. So that's what you need without using calculator. And after that, use a calculator to graph. Okay, that's the first one. And let's practice more. Second one. Domain will be denominator, right? So when denominator is not equal to 0, x is not equal to 3. And the VA is x equal to this number 3. HA, for this question, that will be bottom heavy. Because there's no x on the top, but you do have an x on the bottom. That's why it's a bottom heavy. When it's a bottom heavy, the horizontal asymptotes is y equal to 0. Automatically be 0. As long as the bottom heavy, y equal to 0 all the time. And for zeros, we set the numerator equal to 0. Look at this problem. There's no x on the top. That's why there's no zeros. If no zeros, that means the graph will not cross the x-axis. Okay? And the interval work always be VA and the zeros. There's no zeros, so you only need to put the number 3 on the number line. And before 3, we can check if I'm using 0 to plug in back. I'm going to have a -4 over -3. That turns to positive. After 3, I can use 4. So be negative number over positive number, which is a negative. That's how I do number line. Last step, y-intercept. When I plug in x equal to 0, the y value will be -4 over -3, and that turns to positive 4 over 3. Okay, we've done all this. Now let's graph. Vertical asymptotes at 3. Horizontal asymptotes at 0. And y-intercept 4 over 3, so it'll be 1 point something. And now let's look at look at the interval work, so you're able to graph. Before 3, positive, so be above. And passing through this point and approaches to this line. So that graph will look like this. And after 3, negative, so be below, bounded by these 2 lines. That's why graph will look like this. Okay, that's how we do number 2. Look at number 3. Number 3 will be a little bit different. First, we find the domain. We're doing the same thing to find domain. When we set the denominator not equal to 0, when we set the denominator not equal to 0, I need you to factor the denominator. So it's a better way to factor this question. Let's do top and the bottom together. So for the top, we factor x out. And then we have x plus 3 inside. For the bottom, we have x plus 2 and x plus 3. That's how we factor these functions. After you've done that, we make a denominator not equal to 0. That means x is not equal to -2 and -3. After you've done domain, we're going to do a little bit differently. Why differently? Because look at this question. we have a common factor after we factor this. So we can cancel this common factor. Now we only left x over x plus 2. We're going to using this new equation for all the rest of problems. So now we have x over x plus 2. That's the one we're going to use after find the domain. So VE will be x equal to only one denominator, so only will be one numbers. And the HA, look at this question, also equal powers, so that will be leading coefficient 1. Zeros, we set numerator equal to 0, that means x is equal to 0. Interval works. We always need VA and zeros. So we put -2, put 0. And before -2, I can use -3. So negative over negative will be positive. Between -2 and 0, I can use -1. So when I plug in, -1 over +1 will be negative. After 0, I can use 2, so it'll be positive number over positive. Okay, that means the graph will be above, below, above of the x-axis. And the y-intercept, when I plug in x equal to 0 to either this one or this one, actually doesn't matter. So let's keep using this one. So it'll be 0 over 2, which is 0. Okay, now let's graph. Same thing, VA at -2. HA at 1. And the zeros at here. Y-intercept also at here. Okay, that's all we know so far. After that, actually you're able to use calculus graph. Before -2, it's a positive, so be above and approaches to this 2 line. That's why it will be this. And the -2 to 0, negative, so be below and approaches to this point, passing through this, and the change to positive, approaches to this line. So that's why the graph looks like. And the number 4. I got sick, so that's why my voice is not really good today. Sorry about that. And the same thing for this one. If you want, we can factor this. We keep x on the top because that's unfactorable. Over bottom is x plus 4 times x minus 4. There's nothing can be canceled. That's why we're doing this same thing. You don't need to cancel anything. Domain will make a denominator not equal to 0, so x is not equal to -4 and the positive 4. That means VA is x equal to these two numbers. And the HA is y equal to 0 because this is a bottom heavy. Power 1 on the top, power 2 on the bottom. That's why it is bottom heavy. And the zeros, we make the numerator equal to 0. That's why x equal to 0. And the interval work. So it'll be -4, 0, +4, because we need VA and the zeros. Now let's check. So actually you also can use a calculator. Let's use a calculator. That will be easier. This time, let's plug in this function. Will be x on the top, x squared minus 16 on the bottom. And then let's go to table. Okay, before -4, I can use a -5. So let's go find -5. So y value is a negative, so this will be negative. Between -4, 0, I can use a -3. And that's changed to positive number. So that's a positive. Between 0 and 4, I can use 2. That's also negative number. After 4, I can use 5, and which is a positive. Okay, that makes the process lots of easier. And the y-intercept is when x equal to 0, So 0 over negative 16, which is 0. Okay, now let's graph. VA, so we have 2 VA this time. HA, and the zeros. Okay, you can say the horizontal is able to cross in the middle, but not the two sides. Okay, now let's graph. Negative, before negative 4, so be below and approaches to this 2 line. And then between negative 4, 0 will be positive, approaches this line and passes through this 0. And after 0, the graph changes to negative, so it'll be going down and approaches to this line. And after this line, the graph flips back to the top, so it will be this here. That's a graph look like. Okay, let's do 2 more, I think. For the phi, same thing. Probably is. Okay, how about this way? Okay, we can factor this one. Top is x plus 4, x minus 4. Bottom will be x plus 2 and x minus 2. Also, there nothing can be cancelled. We can just solve this regularly. Domain is denominator not equal to 0. So x is not equal to negative 2 and 2. VA is x equal to negative 2 and 2. HA is y equal to 0 because bottom heavy. Because equal power. So power 2 on the top, power 2 on the bottom. They both are equal. You just look at the coefficient. So it will be 1 over 1. That's why it's 1. Zeros, we make numerator equal to 0. So x is 4 and the negative 4. Interval work, we need the VA and the zeros. So negative 4, negative 2, 2, and the positive 4. Lots of interval this time, so let's use a calculator. Top is x squared minus 16. Bottom is x squared minus 4. Okay, go to table. Okay, let's see. Between negative 4, I can use negative 5. That's a positive. Between negative 4 and negative 2, let's do negative 3. And that's negative. Between negative 2 and 2, I can use 0, so positive. And between 2 and 4, 2 and 4, I can use 3. That would be negative. After 4, positive. Okay. Y-intercept. When x equal to 0, 0, 0, so negative 16 over negative 4 will be positive 4. Okay, now let's graph. VA, so negative 2, positive 2. HA, y equal to 1. Zeros, negative 4, positive 4. And the y-intercept is positive 4. Okay, so graph will be passing through these 3 points and approaches to these 2 lines and follow this interval work. So positive first, that means above. I use this highlighter. Above and across this point, change to negative. After negative 2, that's a positive. So above, passing through this point. And after this one will be positive again. So we'll go back. After 2, negative, so below. Passing through this point and approaches to this line. So the graph will look like this. It's okay, you can just use calculator to graph, as long as you draw all this necessary information on it. Okay, look at number 6. Domain. We solve domain because we don't want to divide by 0. That's why we need to make sure the denominator is not equal to 0. Okay, but look at this question. X squared is a positive. You plus another 4. You know the denominator is not equal to 0 for sure, no matter what's the value of the x. So at this point, the x value doesn't matter anymore. That's why domain will be all real number, because x can be any number. And how about VA? If x can be any number, so there's no asymptotes anymore. There's no gap. That's why there's no VA for this question. And HA is equal power, so it will be leading coefficient 1/1. Zeros, we make a numerator equal to 0, so we can factor this numerator to x plus 3 and x minus 3. So 0 will be x equal to -3 and a +3. After that, interval work. -3, +3, because we need the zeros and the VA. There's no VA, so you only need to label the zeros. Before -3, same thing. If you want to use a calculator, let's do so. Top is x minus 9. Bottom is x squared plus 4. And then table. Before -3, it's a positive. Between -3 and 3, it's a negative. After 3, it's a positive again. And the y-intercept is when x equal to 0, and the y value will be -9/4. Okay, now let's graph. VA, there's no. HA at 1. And the zeros, -3, +3. Y-intercept is -9/4. That's -2 point something. So it'll be here. Now you can use a calculator to graph. Or you can just think about, look at the interval work. Positive, cross this point, cross this point, cross this point, and the positive approaches to this line. Okay, that's how graph look like. 7. Domain is a bottom. Okay, so when this not equal to 0, you can factor bottom to 1 minus x times 1 plus x. So we know x is now equal to positive -1. That make VA equal to positive -1. HA is equal power. So highest power x squared, highest power x squared. So leading coefficient will be 1 divided by -1, which give you -1. Zeros. So we set the numerator equal to 0. Same thing. X squared always be positive. Plus another numbers. You never get this be 0. So there's no such of x make x squared plus 4 equal to 0. That's why there's no zeros. And the interval work just be -1 and a +1. Before -1, if I'm using -2, this will give me negative. Between this, if I'm using 0, this give me positive. After 1, will be negative again. And the y-intercept, when we plug in 0, so we have a 4/1, so which is 4. Okay, now let's graph. VA, so -1, +1. HA is -1. Zeros, no 0. That means graph will not cross the x-axis. Y-intercept is 4. It's here. Now you can use a calculator to graph. Oh, let's look at interval. Negative, so be below. Positive, about, cross this point. And the negative, below again. That's how you do it. That's how you do equal power and the bottom heavy. Now, I'm showing you one question for the top heavy. Top heavy actually, only one thing different. Look at this graph. We do have a vertical asymptotes, but we don't have a horizontal asymptotes. We have a diagonal asymptotes. And this line, we call it a slighted line. And that's why we don't have horizontal asymptotes anymore. We're going to have OA. We're going to have OA, oblique asymptotes. Okay, so your graph going to be look like this. Now I'm show you one. I think one is enough. So first, domain. We're doing same thing. We set denominator not equal to 0. That means x is not equal to 1. And the VA is x equal to 1. Okay, OA. There's only different is OA. How we find the OA? We do synthetic division. Okay, we use a coefficient here, which is 1, -1, -6. And then we divide by this denominator, that will be 1. We'll bring this 1 down. Multiply is 1. And the plus will be 0. And the multiply is 0. Plus -6. And the we call last number is remainder. And we don't need the last number. We only need these two. So when you write your answer, the problem starts with a square. And when you do one synthetic division, the answer should start with x. So y is equal to x, 1x, plus this number. Because it's 0, so just y equal to x. And the zeros, we make numerator equal to 0. So we can factor this to x minus 3 and x plus 2. So your zeros will be 3 and -2. And the interval work, same thing. VA and the zeros. Also, we can use a calculator to find this. We have x squared minus x minus 6 on the top. And the x minus 1 on the bottom. Okay, go to table. So second graph. Before -2, it's a negative. Between -2 and 1, it's a positive. Between 1 and 3, it's a negative. After 3, it's a positive. Okay. Then y-intercept is when x is 0, which will be 6. Okay, now I'm showing you really quick how to graph. VA, same thing, 1. And the OA is y equal to x. This time it's not horizontal. It's a diagonal. So it will be this one. And then zeros, 3, -2. Y-intercept, 6. That's all you need. And then that's the graph. Okay. So we can use a calculator, or you're able to do this by this way. Negative, below, cross this point, going up. And then after 1, negative, cross this point, and approaches to this line. That's it. That's how you do the top heading. Okay. And now you don't have to do 3. You don't have to do 3. You need to finish the homework page about those questions. And when you finish, let me know. And for the last part, the partial fraction, I want you to try to read the instruction first to see if you're able to do it now. If you're not, let me know. Because today the class is over, the student is coming to take tests with me. So I'm unable to do it now. So let me know if you need I go over that part. I can do another video for you. Okay, that's it for today.